Now we will discuss some of the fundamentals based on kinematics of curvilinear motion. We will talk about something related to kinematics of curvilinear motion. So as we earlier discussed, basically in kinematics of curvilinear motion, we are interested in projectile motion. So the projectile motion, like we can say the motion of a body is not in x direction, not in y direction. It's a combination of motion in x and y direction. So I am drawing the graph showing motion along y direction, motion along x direction. And suppose I am projecting something which is making an angle theta with the horizontal, and the motion, if I am describing by this parabola, so this motion is called projectile motion. So this we can say that projectile motion. So in projectile motion there are some terminology. I am just defining the terminology here. So theta is nothing but angle of projection which is making with horizontal, that is with x direction. U is the velocity of projection, or we can say that initial velocity. So these are the terms which is useful in the projectile motion. And in our daily life, if we throw a ball, if we throw a cricket ball from one place to another place in air, then we can the motion of this cricket ball, we can say that it's a projectile motion. So there are a lot of equations which describe the different physical quantity related to projectile motions. So now I will not go into the details of how we can derive these things. I am just writing important formulas which will be useful in projectile motion. So first one, that is maximum height. Maximum height in case of projectile motion, suppose it is denoted by h max. So maximum height will be u square sine square theta by 2g. This one is the formula for maximum height. Similarly, the formula for time required to reach maximum height. So it will be u sine theta by g. So total time of flight equals to t equals to 2u sine theta by g. Range is nothing but horizontal distance traveled. This is the range. Suppose I am at point O and now the body is at point A. So this O to A distance, horizontal distance, it's called range. So formula for range is u square sine 2 theta by g, that is for range. And for maximum range, what will be the value of theta? So like for maximum range, theta will be 45 degrees. So these are some of the important things related to the projectile motion. So whenever the problem based on projectile motion will come, then directly we can apply this formula for solving problem based on projectile motion. Problem based on projectile motion. So here I am just writing the problem. Find maximum range of a cricket ball projected with a velocity of 15 meters per second. If the ball has a range of 20 meters, find the least angle of projection and least time taken. So here in this problem, we have to find out the maximum range of a cricket ball, and then in the next part, the range is given 20 meter. On the basis of that, we have to find out least angle projection and the time taken. So now we are solving this problem. So first we will go for maximum range. So we know the formula for range was to u square sine 2 theta by g, and we know for maximum range theta will be 45. So R max, that is maximum range, will be u square sine 2 into 45 degree divided by g. So R max will be u square, that is sine 91 g. So u is given, that is 15. Here u is given, that is 15 meter per second. So 15 square divided by 9.81, 225 by 9.81, the value will come around 22.935 meter. So the maximum range for this problem is 22.935 meter. In the second part of the problem, range is given, that is 20 meter. We know range equals to u square sine 2 theta by g. To put the value of range here, that is 20 u square sine 2 theta by g. So 20, we know the value of u, that is 15. So 15 square sine 2 theta is 9.81. So I can write sine 2 theta equals to 20 into 9.81 divided by 225. So this value will come around 0.872. So theta will be 30.346 degree or 60.692 degree. So the least angle here, least angle of projection will be 30.346 degree. Now the time of flight, or we can say that least time of flight, because it will be based on least angle of projection. Time of flight t. So we know t equals to 2u sine theta by g. Value of u is 15, and we have already calculated least angle of projection. So we need to put this thing 30.346 degree divided by 9.81. If we solve it, we will get 1.545 seconds. So this one is the least time of flight because it is based on least angle of projection. Let's take another problem based on projectile motion. Problem based on projectile motion. Here I am describing the problem with the help of a diagram. A tower is given A, B, and the height of the tower is given, that is 60 meters. and a ball is projected from the top of the tower with an angle of 30 degrees and initial velocity is 20 meter per second, and this ball will hit the ground at a point B, which is on the same level where A is situated. Now we are interested in the value of R. So now we have to find out what will be the R. I am again repeating the problem. A ball is projected from the point B, which is at the top of the tower, having the height 60 meter. The ball is projected with the velocity 20 meter per second, and which is making an angle 30 degree with the horizontal, and this ball will touch the ground at the point B. Now we are interested in this distance R. So now see how we can solve this problem. So here we know the AB. So the total vertical displacement of the ball is 60 degree. So in vertical direction, it's a motion. It's a vertical direction. It's a motion under gravity. So we can say that the vertical motion will be motion with uniform acceleration. So we can apply any of the three equations based on motion with uniform acceleration. So I am using the equation S equals to ut plus 1 by 2 at square. But for vertical motion, I am writing for vertical motion. So for vertical motion, the vertical velocity, the initial vertical velocity u will be 20 sine 30, because 20, the component of 20 in vertical direction, it will be 20 sine 30, and in horizontal direction will be 20 cos 30. Cos theta, so theta is 30, so we can write cos 30. Here we can also write sin 30. 20 sin 30 is in vertical direction, 20 cos 30 is in horizontal direction. So initial velocity. So for this thing, and now we have to see our sign convention. We know our sign convention here: upward, positive, downward, negative. So uh, so the ball will travel the distance from B to A. It is in vertically downward direction, so negative minus 60. U, it is in upward direction here. You see, it is in upward direction, so it is positive plus 20 sine 30 into T plus 1 by 2 into it's a motion under gravity, so acceleration is G, and G is always acting in downward, so negative T square. So here we will get minus 60 equals to 20 sine 30 is 1 by 2 T minus 1 by 2. Let's take G value 10 meter per second square T square. So here we are having minus 60 equals to 10T minus 5T square equals to 0. So we are having 5T square. So here we are having 5T square minus 10T minus 60 to 0. So we got the equation, quadratic equation in terms of T, that is 5T square minus 10T minus 60. So we can solve it. T will be 2 plus minus, it is 4 plus 48 divided by 2. So we will get 1 plus minus root 30. So we will get the value T equals to 1 plus 3.6 equals to 6. So I am not taking the negative sign here because the time cannot be negative. So I am just taking the positive sign. So we got the value of T, that is 4.6 seconds. I'm again drawing the diagram here. This one is point A, B. This is the point B. Suppose, okay, point O. That is B. We are projecting here at the speed of 20 meters per second. Here angle is 30 degree, and this ball coming here, and now we are interested in this value. So we know the component here, that is 20 sine 30 degree. Component here, that is 20 cos 30 degree. So for horizontal motion, velocity will remain same. So in that is horizontal direction, we are having 20 cos theta. 20 cos theta is 20 cos 30 degree. So for range R, you can write velocity into time. So for horizontal direction, we are having 20 cos 30. Time we have already calculated, 4.6. So R will be 20 root cos 30 root 3 by 2, 4.6. So we will get 79.67 meters. By this way, we can calculate the range of distance AB, that is 79.67. We take another problem based on projectile motion. Problem based on projectile motion. Here I am drawing the diagram for understanding of the problem. This is the two axes here, X and Y. Here a shell is required to project such that it will just cross the wall of the fort. This one is the fort AB, and the height of this fort is 20 meters. The distance from the gun is 16 meters, and we are interested in U and theta. So I am again repeating the problem. A shell is required to project such that it will just cross the wall of the fort. The height of the wall is given here AB, and the shell is just required to cross the wall, and the wall height is given 20 meter, and the distance between the gun and the wall, that is OB, is given 60 meter. And here we are interested in what is the velocity of projection and what will be the angle of projection. So we have to find U. Problem, maximum height is given H max, that is 20 meter, and if we see here, this is 60 up to this thing, so it should be the 60. So the range will be 120. So we can apply the formula for maximum height and range. So maximum height, we know it is nothing but u square sine square theta by 2g. So we are having 20 equals to u square sine square theta by 2g. Similarly, for range, we are having the formula u square sine 2 theta by g. So 120 is to u square, and for sine theta, sine 2 theta, I can write 2 sine theta cos theta by g. So we are having two expressions. 20 is to u square sine square theta by 2g. 120 is to u square into 2 sine theta cos theta. Again writing the equation here, that is 20 is to u square sine square theta 2g. Let's say it's equation number 1. And the second equation is 120 plus 2u square sine theta cos theta divided by g. Let's say it's equation number 2. On dividing 1 by 2, we are having 1 by 6 plus 2 tan theta by 4. So tan theta I can write that is 4 by 6, so 2 by 3. So theta will be tan inverse of 2 by 3. So tan inverse of 2 by 3 is nothing but 33.69 degrees. So we can easily calculate the angle of projection, that is 33.69. If we put the value of theta in equation number 1, so putting value of theta in equation 1, so we can get 20 equation 1 u square sine square theta 2g. We are having 20 equals to u square 2 into 9.81 for sine square theta. We are having sine 33.69 square. And if we solve this thing, we get u square 20 into 2 into 9.81 divided by sine square of 33.69 degree. So we will get u square equals to 1274. So u will be square root of 1274. This one value will come 35.69 meter per second. So the velocity of projection will come 35.69 meter per second. So before starting the next problem, I would like to discuss a very good analogy between the translatory motion and rotatory motion. So let's take analogy between translation and rotational motion. So here I am drawing a table. You will see what are the different terminology we are using for that here. So translatory motion, and here we are having rotational, or we can say that circular motion. In translatory motion, we are interested in linear displacement, and generally we are denoting this displacement by S. In rotational motion, we are interested in angular displacement. It is denoted by theta. Here we are interested in linear velocity in case of translatory motion. Linear velocity. Generally we are denoted by u. Here we are interested in angular velocity, and we are denoted by omega. In case of translatory motion, we are having linear acceleration, which is denoted by k. Here we are having angular acceleration, denoted by. So in case of translatory motion, we are having the equations based on motion with uniform acceleration. So similarly, in case of rotational or circular motion also, we can write the same equation, but the notation related to rotational motion or the problems based on motion with uniform acceleration. So now I will write the equations for motion with uniform acceleration, or we can say that motion with uniform angular acceleration. Angular acceleration. So I am writing the first equation, that is nothing but omega equals to omega naught plus alpha t. Similarly, we know the equation based on motion with uniform acceleration in rectilinear motion, that is nothing but v equals to u plus at. So in place of v we are having omega, in place of q we are having omega naught, that is initial angular velocity. In case of linear acceleration a, we are having alpha, that is angular acceleration b. Similarly, second equation we can write for circular motion with uniform angular acceleration. That is theta equals to omega naught t plus 1 by 2 alpha t square. Similarly, we know the same equation for translatory motion, that is s equals to ut plus 1 by 2 at square. Similarly, we can write the third equation also, omega square equals to omega naught square plus twice alpha theta. So these three equations we can use when the motion with uniform angular acceleration is mentioned in the problem based on rotational or circular motion.